Press start.
Hello, I'm Officer Knights. We will learn about Euler's number. Euler's number is a mathematical constant, denoted by E equal to 2.71828. We can say in many ways. It is the base of the natural logarithm. It is an expression that arises in the study of compound interest. It can also be calculated as the sum of the infinite series. Let us prove the following. E is equal to the sum of 1 by n factorial, where n begins with 0, then 1, 2, 3 and so on. 0 factorial is 1, but it cannot be 0. 1 factorial is 1, 2 factorial is 1 multiplied by 2, is 2. Now, 3 factorial, that goes in multiplication sequence, that is 1 multiplied by 2 multiplied by 3, that is 6, and so on. This proves the value to obtain 2.71828, but some users find through the web that goes up to 50 decimals, that is 2.718281845271747135267249757247093699995. For one thing, about compound interest. The guy who teaches monetization and banking, named Shadow the Hedgehog. Shadow.
Yeah?
What is compound interest?
Let me find out for a while. What's your name?
I'm Knights the Nightmaren.
Okay. Compound interest is the addition of interest to the principal sum of a loan or deposit.
Can you work out with the given Euler's number?
Wait, what?
It's given by the value 2.71828, that can be worked with compound interest. Shall I show you a question?
Okay.
What's your favorite currency?
Let's take US dollars.
Alright, take the principal amount $1, rate given for 100%, and the interest is compounded annually, n equals 1. Prove it. Will the cost be doubled?
Okay, if principal amount is $1, rate 100%, and annual compound interest at n equals 1. We write total amount equals principal times 1 plus r over 100n in the entire n exponent. That becomes $2 as the total amount. So, yes, we prove that the cost is doubled annually.
If it is semi-annually, in the next question, others will remain fixed values. Say n equals 2. What's the value?
That would be $2.25, a little more than double.
If it goes all the way to every a second, this might return it into the Euler's number form.
Yeah, so biggest exponent would return the value infinitely large.
Okay, that's the great idea of about Euler's number. See you, Shadow.
See you then.
Like, comment, and subscribe now.